Hello everyone. In this video we will study circles as polar curves. Let me start with one example. Sketch the polar curve given by r equal to 3 sine theta. Well, to start with we need to have some values, some points. So some values of theta. Theta 0, pi over 6, pi over 4, pi over 3, pi over 2. Let's just go up to that point. R equal to 3 sine theta. For theta 0, this is 0. For theta pi over 6, sine of pi over 6 is 1 over 2. So this is 3 over 2. Pi over 4, the sine of pi over 2 is root 2 over 2. There is 3 multiplied. And then root 3 over 2 is 3 multiplied. And then 1, which is 3. So let's find these points. For theta 0, so this is this ray here, the r is 0. For theta pi over 6, it's 3 over 2. It's 1.5, yes? So on this ray here, you see this ray, that is 3 over 2. On pi over 4, you see root 2 is 1.4 about, divided by 2 it is 0.7, so this is 2.1. So I go up to 2.1, and then on pi over 3, this is about 2.5 or something like that. So this will go up to that point there. And on pi over 2, it is 3. So if I connect these guys together, you see that, well, there is a half circle kind of thing there. And then I can continue a little bit more. Actually, the way this works is that, well, I put 3, this one, 3 pi over 2. This will give me something here about this point. And then for this guy, I will get about 2.1. And then for 5 pi over 6, I'll get this guy here, and then go back to 0. So that will form the other half of the circle. But I have gone up to pi. So I started from 0, I've gone up to pi. What will do the rest? So if, let's do some values for that. So if theta is, let's say, 7 pi over 6. Sine of 7 pi over 6 is negative half. So multiplied by 3 is negative 3 over 2. So on this ray, r is negative. R is negative means that it needs to go to the other direction. And this is negative 3 over 2 and theta 7 pi over 6. So I get the same point. For 5 pi over 6, 5 pi over 4, I get negative root 2 over 2. There's a 3 multiplied there. So with negative 3 root 2 over 2. And if I again do the same thing, I will go get that point there. So I'm going around the circle actually another time. So from theta from 0 to pi goes 1, and then from pi to 2 pi, that's another round. Well, this is just, at least we found some points, and then we looked for the pattern. But you may not be happy with my claim that this is a circle, because circle is very precise shape. Why, for example, it's not oval, or why it's not some strange shape which is closed. Well, to show that, I have a trick here for you that you have to learn and apply it anytime you want to turn a polar equation to a Cartesian equation. Because in Cartesian equation, we know what is the equation for a circle. X minus a squared plus y minus b squared equals to r squared. Yes. To get there, I multiply both sides by r. So it will be r squared 2 times r sine theta. R squared is, remember, is x squared plus y squared. So I have x squared plus y squared there equals r times sine theta is y. So this is 2 times y. Now, my claim is that this is an equation for circle. How is that so? If I bring that 2y to the left-hand side, then I try to completely square this guy. Sorry, did I use, oh, sorry. This must have, okay. So this should be 3, should be 3, and this is 3. So in other words, I want to write this one as a y minus something squared, and then the another terms. For first time squared plus twice as second one. So this is y squared, let me write it here, y squared minus 2 times 3 over 2 times y, yes? So then the second term could be 3 over 2, but I'm off by square of that, which is 9 over 4. I added 9 over 4 to the left hand side, so I need to add it to the right hand side as well. Okay, so this gives me x squared plus y minus 3 over 2 squared equals to 9 over 4. And this guy here, as you see, as I claim, is circle centered at, you see, x minus 0 squared, so it is 0. Y is 3 over 2 with the radius square root of this guy, which is 3 over 2. So if I go back there again, you notice that my center is 0, 3 over 2, and the circle, the radius is 3 over 2. Okay, so you can either do that or just go point by point and you'll notice what's going on there. Let's do another example. Sketch this one. Oh, this was supposed to be another function. Let me change that. This was supposed to be 2 times cosine theta. R equals to 2 cosine theta. You can go ahead to the table, but I will use the trick that we just used. So R is 2 cosine theta. Multiply both sides by R, so you get R squared equals to 2R cosine theta. And then R squared is x squared plus y squared. R cosine theta is x. Now I want to gather all x's in one place, so I bring that 2x to one side, and this is 0. Now if I add 1 to this, this is square, completely squared. That will be x minus 1 squared. But since I added 1 to the left hand side, I must add 1 to the right hand side. So this is what I have. So then you see that this is a circle centered at 1 and 0. You see x minus 1, that is the x coordinate of the center, and y minus 0 squared, so that is 0 there, with the radius square root of 1, which is just 1. So if you want to sketch that, you try to do it at least once. So it will be centered at 1 0, radius 1, so it will go around and come back, something like this. And well, with the same kind of argument in general, you can see that okay, this is the fact. R equals to 2, but not 2, A sine theta plus B cosine theta is the equation, the polar equation for the circle centered at, so the sine part will generate the y coordinate of the center, but actually half of that. And B part, the coefficient of cosine will generate the coordinate for the first coordinate of the center. So B over 2 centered at B over 2 and A over 2 with the radius square root of A squared over 4 plus B squared over 4. So in general, that is the case. Well, remember that R equal to constant was also another circle. Those was circles centered at the origin, but here now we are good with these cases.